Welcome to question number 9. In this question we're given a geometric series has first term a and a common ratio r. The second term of the series is 4 and the sum to infinity is 25. And for part A we're asked to show that 25r squared minus 25r plus 4 equals 0. Now you may like to pause the video, have a go at this question. On the other hand, if you're struggling with geometric series, have a look at our tutorial and hopefully we'll take you through all the different kinds of concepts that you're likely to face with the geometric series, and that should help you throughout this question. Okay, welcome back. Let's just see how you got on in showing this result. Okay, so what I'd have to do is use the information that I've been given somehow. So we're told first of all that the second term is 4. So we're given that the second term is 4, and that would mean that the second term, the first term is a, the second term would be a times r, so that'd be ar, and that equals 4. Now, I can't do much with this equation, I can't solve it, so therefore I'll put it on hold and call it equation number 1. Also, I'm given that the sum to infinity up here is 25, so we tend to write that as S infinity for short, and that equals 25. Now the sum to infinity for a geometric series is given as a, the first term, all divided by 1 minus r, and that will equal the 25 then. Okay, so I'm going to call that equation 2. Now, when I've got to prove this result, what I notice is that there's not an a in it. And so that does seem to suggest that I need to eliminate a between these two equations, 1 and 2. So in order to do that, I'm going to turn to equation 2 because it just seems the more complicated, and get rid of the fraction 1 minus r, and I can do that by multiplying both sides by 1 minus r, so that from 2 I get that a equals 25 times the 1 minus r. Okay, and I'm going to call this number 3. And so what I'm going to do now is substitute equation number 3 into equation number 1 in place of a. So it's going to be that this is going to be multiplied by r to equal 4. I'm going to slip the r in after the 25, so therefore I get, well, better say actually, let's just rub this out. Let's say that we get sub equation 3 into number 1, and so therefore I'm going to have 25 times r times the 1 minus r, that's going to equal 4. So expand the bracket out and we get 25r minus 25r squared equals the 4. So it's starting to take shape now. I can see it's looking very similar to what we've got to show. Looking at that, I can see that we've got a plus 25r squared, then a minus 25r. That would seem to suggest that I ought to multiply both sides by minus 1. So if I do that, I'm going to get minus 25r plus 25r squared will equal minus 4. And then if I add 4 to both sides and just rearrange, I'm going to get the result that I require. Let's just scroll up just a little bit. So therefore, if I do that, I'm going to get 25r squared minus 25r plus 4 equals 0. Okay, and that proves our result. And if you did that, well done. You should get 4 marks for that. Okay, so put the 4 marks in there. Okay, moving on to part B now. Let's just scroll up, give ourselves some room. In part B, we're asked to find the 2 possible values of R. So I'll give you a few moments to do that. Just pause the video, come back when you're ready. Okay, welcome back. See how you got on. So to find the 2 possible values of R, all we need to do is factorize the answer we had in part A, the quadratic above. So if we factorize that, we're therefore going to carry on and get 2 brackets equals 0. It'll be 5R and 5R because they will multiply together to give 25R squared. And then it's a -1 and a -4. Those are the 2 numbers that multiply together to give them +4, and we get our -25R in the middle. Okay, so solving that, we would have that therefore 5R minus 1 equals 0, or 5R minus 4 equals 0. Solving that leads us to R equals 1/5, or R equals 4/5. Okay, so hopefully you're able to do that, and if you did, you would have got yourself 2 marks. Moving to part C then, we have to find the corresponding 2 possible values of A. Okay, so if you'd like to give that a try, just pause the video, come back when you're ready. Okay, welcome back. Let's see how you got on. Well, the 2 corresponding values of A, all we need to do is put R equals 1/5 and R equals 4/5 up into the equation number 3 up here. Okay, so let's just say that we'll sub R equals 1/5 into equation 3, and so what that gives us is that A equals 25 times 1 minus R, that's 1 minus 1/5. So 1 minus 1/5 is 4/5, and 4/5 of 25 is 20, so therefore A equals 20. Let's do the same again for R equaling 4/5. I'll just draw it down here. So we would sub R equals 4/5 into 3. Okay, that's that. And if we do that, we get A equals 25 times 1 minus 4/5. 1 minus 4/5 now is 1/5, and 1/5 of 25 is 5. So therefore we have A equals 5. So there are our corresponding values for A. They are 20 and A equals 5. So hope you got that right, and again if you did, the marks that were given for that were 2.